Hello guys, welcome to Smoy Someone Maths Tutorials. So the today's lesson will be doing the differential calculus, whereby we're going to sketch a cubic function, and also I'm going to explain how do we factorize a cubic polynomial, and also how do we find the stationary points and the point of inflection, right? So now we can start. So to sketch a cubic function, we follow the following steps. The first step is to determine the shape of your function by taking these two facts into consideration, right? If your a is greater than 0, then your function, it will increase, decrease, and also do what? Increase. In simpler terms, your function is going to look like this. So meaning whenever you draw your graph, when A is positive, you must expect something like this. Even though when you're drawing, you must draw something which looks like this, right? Whereby your function increases here, like it increases here, and decreases here, and also increase here, right? And then now, if your A is less than 0, whereby your A is negative, your function decreases, increase, and also do what? And also decrease. So you are going to have an equation which looks like this, right? So meaning when you draw, you must draw a graph which look like this one, whereby it decrease, increase, and decrease, right? If your a is less than 0. So now we can see that, okay, after we find the x and the y intercept, for x you let For x-intercept, you let y equals to 0, right? And you must be able to factorize a cubic polynomial. That's what we are going to talk about. I'm also going to show you how do we factorize a cubic polynomial, right? And then the third step, find the stationary points. We're also going to talk about it. Find the point of inflection and then plot your graph, right? So meaning if you have these 5 things, then it is going to be easier for you to draw your graph. So now let's do this example. It says sketch f of x, whereby it's given by x cubed minus x squared minus 5x minus 3, right? So the first thing from the steps is to do what? Is to determine the shape. Is our a is positive or negative? It's positive, right? How do we say it is that it's positive if someone get confused? Remember that we have this equation, it's like this, or it's from this one, right? Where is ax cubed plus bx cubed cx plus d? So what is a? We can see that a from the cubic function is always what? The coefficient of the x cubed, right? So we can see that from this equation that we are given, our a is what? Is positive, right? So now we already saw that our a is positive, so meaning we expect our graph to look what? Like this, whereby it increase, decrease, and also to what? Increase. So now we are going to find the x and the y intercept, right? Which is the second one. Finding what? We can start by finding the x-intercept. How do we find the x-intercept? We let y equals to 0, right? We let y equals to 0. Where's the function? The function of us is given by f of x is equals to x cubed minus x squared minus 5x minus 3, right? So now we let this one equals to 0. F of x, remember, is equals to f of x is like y. So now we have x cubed minus x squared minus 5x minus 3, right? So how do we solve this? We can see that this is a what? Is a cubic polynomial. So therefore, how do we solve a cubic polynomial? We are going to use what? I'm not sure about the spelling, guys. The synthetic division, is it synthetic? I'm not sure about the spelling, guys. Synthetic division. We are going to use a scientific division. So meaning whenever we factorize a cubic polynomial, we are going to use what? I prefer using the scientific division because it's the one which is simple. So how do we use the scientific division? The first thing that you write, you're going to write the L, which looks like this, right? After writing it down, then you need to take or write down the coefficients of each term from the given polynomial. We can see that the first term is x cubed, right? And the second one is -1. It's x squared, right? So what is the coefficient of x cubed? It's 1. We write it here. The coefficient of x squared is -1. The coefficient of 5 of -5x is what? -5, and the last one is what? It's -3, right? After writing them like this, we now going to determine what? We need to determine a factor of the polynomial, right? How do we determine a factor of the polynomial? We're going to use the factor theorem. So meaning like you are given f of x is equals to x cubed minus x squared minus 5x plus 3. So you need to take any values. You can start from negative to positive. You take one value. If let's say for instance you take 1, and then you need to plug a 1 here from x cubed and also from x squared. Where you see x, you're going to plug 1. And if you get 0, that is your factor. But then if you don't get 0, and then you continue checking other values like 2, -2, 3, -3, right? So from this one, we plugged -1, and we saw that the -1, it give us this it give us 0, right? So meaning if when we plug -1, it give us 0. So therefore it means our x plus 1 is a what? Is a factor, right? Because we plugged f into -1, and then we found what? 0. So meaning x plus 1 is a factor, right? So we are going to write the value here, which is -1. We don't write plus 1. The value that we plugged and then calculated it, and then we found that the answer was 0. We take it the way it is, and then it was what? It was -1. That's why we write -1. After here, what we are going to do, the first value here from the this L, we write it, we take it down the way it is, which is what? The first value here, we can see that it's 1, right? After writing 1 like this, then now we need to take this value that we take it down, and then we multiply it by what? By this -1 here. By this -1 here, right? Now guys, by this -1. So 1 multiplied by -1, it gives us what? -1. We write it where? From the second term, right? We can see that the second term is -1, the third term is -5, and the fourth term is -3. And from the second term, we can see that we have -1 and -1. What is -1 plus -1? It gives us -2, right? Then after we take this -2, we multiply it with what? With -1 here, like I said. Therefore, -1 multiplied by -2 multiplied by -1, it gives us what? 2. Therefore, we write it from the third term. And then 2 plus -5, it's going to give us what? -3, right? After writing it down, we do the same thing. -3, it's like a pattern. -3 multiplied by -1, we are going to get what? +3. And 3 plus -3 is equals to what? 0. And always, the value which the last value that you're going to write, it has to be 0. If it doesn't give you 0, it means you made a mistake somewhere. So you need to check, because this is a reminder. Even when you use a quadratic, a long division method, you're going to see that you're going to get 0 here, which is your reminder, right? So now, what are these values that we found? We can see that we found 1, -2, and -3. What are these values? The first value that you found here, it represented by what? Is the x coefficient of x squared, right? It's the coefficient of x squared, the first value here. And the second value here is the coefficient of x. And the last value is the constant number, which mostly is represented by what? By c, right? So now, meaning we have what? We have x squared minus 2x minus 3, right? We have this thing, right? So and then we can close the bracket. We can see that the coefficient of x squared is what? Is 1, which is here. And the coefficient of x is what? Is -2, which is here. And the last one, which is the constant, which is -3, it's here. And remember, we need what? We need to have the equation. We need to write that equation that we have. Remember that it's a what? It's a quadratic, and we need to have what? A cubic. And we said that f into -1 is equals to 0. And then we found that x plus 1 is a factor because of, we said, because of its -1, therefore x plus 1 is a factor, right? If it was, let's say, f of -2 is equals to 0, so meaning our x plus 2 is a factor, right? So what is the factor here? We saw that f into -1 is equals to 0, so meaning our factor here is going to be x plus 1, right? So now we know how to solve this. When we factorize this, we are going to have something like x plus 1, x minus 3, and x plus 1. We can see that we have x plus 1 and x plus 1, whereby after having this value is equals to what? Remember, this value is equals to 0. Let's not forget to write 0. Remember, this value is equals to 0 because we are solving for what? For the cubic function, right? So now we can say x is equals to 1, or x is equals to 3, or x is equals to -1. I mean, guys, -1. Yes, we're going to have something like this. So you can only write 1 for x is equals to -1 because you can see that it repeats itself. Né? So remember, we said from the steps, after write in coordinate form. How do we write in a coordinate form? For -1, we are going to have -1 and 0, or for 3, we're going to have 3 and what? And 0, right? So meaning we're done finding what? The x-intercept. Let's now find what? The y-intercept, right? So finding the y-intercept, it's easy. You don't need to use those methods. Y-intercept, we let x equals to, sorry guys, we let x equals to 0, right? So we know that our equation is f of x is equals to x cubed minus x squared minus 5x minus 3, right? And then we let x equals to 0, so meaning we're going to have 0, 0, 0, and then our answer is 3 here, right? Of x is equals to 3. So meaning the values we are going to have 0 and -3, right? So now we are done finding the x-intercept and what? And the y-intercept. So now we're going to find what the stationary point. So I'm just going to erase those things here. You can just copy them somewhere because I don't have a space here, guys. Okay, guys, now we are onward on the step 3, whereby we find the stationary point. What you need to know about the stationary point is that the first derivative of x is equals to 0, right? This is the first thing that you need to know. And remember, whenever determining the stationary point, it's like determining the turning point. So we need to do what? First, find the first derivative and let f of x equals to 0, right? To solve. And let the first prime of x equals to 0 to solve for x. That's why I wrote it here. So meaning we need to have 1 here, right? So now, how do we find what is the value? What is the given equation? You can see the given equation is x cubed minus x squared minus 5x minus 3. And then we differentiate this, right? So how do we differentiate this? If you don't know how to differentiate, there is a video whereby I explain how do we differentiate. I'll leave a link in the description below so that you can go to check it if you don't know how to derive. So we're going to have 3x squared minus 2x minus 5, right? But then we said, remember this is prime, guys. Let me write it clear. Yeah, remember we said we said the first derivative of x is equals to what? 0. So where we see the first derivative, the derivative, we can replace it with what? With 0. So meaning we're going to have 0 multiplied by 3x squared minus 2x minus 5. And then we solve for what? For the x values. Therefore, we're going to find that our x values is going to be 5 over 3, or x is going to be -1, right? Remember, we need to write it in what? In the, now what do? We need to subtract these values from what? From the original given equation. So meaning for f of 5 all over 3, we are going to have 5 over 3 cubed minus into 5 over 3 squared minus 5 into 5 over 3, right, minus 3, which is going to give us -256 all over 27, right? So now we do what for -1. So for -1, we're going to have -1 cubed minus -1 squared, -5 to -1 minus 3, which is going to give us 0, right? So meaning the values that we have now for the turning points is what? It's 5 over 3, and the y value of it's -256 all over 27, and we also have what? -1 and what? And 0, right? Then we are done determining the stationary points. So after determining the stationary points, and also here, guys, I'm just going to erase those things so that we can talk about how to find the point of inflection. Okay, guys, now we do what? The fourth step, which is what? Finding the point of inflection. The point of inflection is the second derivative, right? So, and then we know that from the second derivative, we always let f of x equals to 0, right? So remember that So meaning we need to differentiate this function to the second derivative, meaning we're going to differentiate first and differentiate it again, right? So differentiating the first derivative is going to be 3x squared minus 2x minus 5, and the second derivative is going to be 6x minus 2, right? And we said we let the second derivative equals to what? 0, and then we're going to solve for what? For x, right? So second derivative is equals to 0, then we're going to have 6x minus 2, right? Therefore we can have 2 is equals to 6x. Therefore we can see that our x value is going to give us what? 5 over 3. Nah, not 5 over 3, wait. It's going to give us 2 over 3, 2 over 6, which is 1 over 3. Let me remove this one. Okay guys, this is how you find the point of inflection. After finding the point of inflection, you can find the y value of the point of inflection, meaning you're going to subtract it from what? From the original equation. So we are going to have 1 over 3 into 1 over 3 cubed minus 1 over 3 squared minus 5 into 1 over 3 minus 5, right? Which the answer is okay guys, our answer is negative 182 all over 27, meaning the points of the coordinates of the point of inflection is 1 all over 3 into negative 182 all over 27. So you saw that whenever we determine the point of inflection, we derive twice, right? And whenever we determine the stationary point, we derive once, right? So yeah, you need to remember those things. When we find the point of inflection, we derive twice. When we find the stationary points or the turning points, we derive once, and then let the first derivative equals to 0, right? So now we are going to draw or plot the graph using the values that we have. So I'm just going to erase here. Okay guys, and then after you draw your Cartesian plane, then what you are going to do, you're going to start by plotting the x-intercept. And we saw that our x-intercept, it was 3 and 0 and negative 1 and 0, right? So 3 and 0, we can put them here, whereby we have 3 and 0 here, and then here we have what? Let's say it's negative 1 here, which is negative 1 and 0, right? Then after, remember the first one was determining the shape. So we expect our graph, we need to draw our graph to be something like this, ne? So don't forget. So after plugging it, now we're going to plug the y-intercept, where x is equals to z. So y-intercept, let's say, let's put it here, whereby the values is 0 and negative 3. If you still remember, it's 0 and negative 3, which they are here. What about the turning points? The turning points, here they are from here to somewhere here, right? This is the turning point, which is what and what? Which is 5 over 3, 5 over 3 and what? And negative 256 all over 27, right? So you can see that I didn't use a ruler to write like 1, 2, 3, 4, 5. So obviously guys, it was going to take time. So you just plug those values the way you can, né? And then you can see that okay, now we are done. So how do we draw it? Okay, we expect something like this. So meaning we expect a graph to look like this, right? We can see that, okay, here we don't have a value. So meaning this, it has to go down, and this, it has to come here, right? And then this is the turning point. It means it needs to go up, right? So meaning this is the graph that you are going to have, guys. You see how simple it is to draw this graph. Whenever you have those values, you just plug those values the way you can, and then you draw your graph. Then that's it, we are done. So from this, you saw that we talked about um, to factorize a cubic polynomial. If you still need more examples, just tell me. I'll do a video whereby I explain factorizing a cubic polynomial in fully, and also for the stationary points and the point of inflection. So we are done with to sketch a cubic function. If you have a question, you can leave a comment behind, and let's not forget to subscribe, guys, please. Let's not forget to subscribe. So Tango, enjoy your day.